to watch this little video here, and maybe this will help out as well. Well, let me forget to do 621 chapter quiz when we get done with this, okay? Or we can do that right now. How about that? One we did, right? That's gonna be A. What about 2?
Two technicians are discussing what could be the cause of slow cranking and excessive current draw. Technician A says that an engine mechanical fault could be the cause. Technician B says that the starter motor could be binding or defective.
Excessive current draw, slow cranking. What do you think?
We're doing a chapter quiz.
Slow cranking.
Yes, we are.
Draw.
621.
Mechanical fault
Question number 2.
because
Oh, are we late?
the starter
Yes.
motor.
I'm sorry.
Both. I mean,
What do you think?
both.
Mm-hmm. Okay, C for number 2. We did 3. We did 4. What about 5?
Technician A says that a discharged battery lower than normal battery voltage can cause solenoid clicking. Technician B says that a discharged battery or dirty, corroded battery cables can cause solenoid clicking, which is correct.
What do you think, Terrence?
Number 5,
Mm-hmm.
both.
It is both. Slow cranking by the starter can be caused by all these except for which one?
Is it D?
C.
Yeah, I'm going with C.
See?
Engine
Yeah.
mechanical problem.
I would say D.
I think it's D too.
All right, we're looking for one that will not cause slow cranking. If there is an open in the neutral safety switch,
That's
it
not
won't
gonna have
crank
any
at all,
connection at all.
okay? It won't crank at all.
So it's D.
It is D. Open circuit will not crank, okay? The rest of those would do it. Lower discharge battery, corroded dirty cables, engine mechanical problem, meaning the engine doesn't turn over freely. Bench testing a starter. This question is going to be on the test. It's both A and B. If the clearance between the starter pinion and the engine flywheel are too great, what's going to happen?
D.
D?
Yeah.
D is not the right answer.
So then
C.
it's B.
D?
E.
Would it
I
be C?
roll
C. Cat.
Mm-mm.
it. A.
A. High pitched whining sound during cranking.
If there's too, the clearance.
Too much
between
clearance
starter
between the drive pinion and the flywheel, yeah.
is too great. See, I wouldn't think that, if it was too great, I wouldn't think that there would be a connection at all.
Well, if it was excessive, yeah, then it wouldn't.
Well, that's what, when it
Yeah.
says too great, that's what tells me, like, you know
Well,
what I mean?
The reason they say that is because some starters have to be shimmed to set the clearance between it. And if it's too much, it'll cause a high-pitched whining sound, which in that case, you would know you would probably have to remove a shim, get it a little bit closer to the, drive closer to the flywheel.
Okay, but you said that the shims aren't used anymore.
Right. Most of the starters just bolt right to the engine. There's no shims anymore. These are older style starters. Technician connects one lead of the digital voltmeter to positive terminal. Battery of the starter solenoid and cranks the engine. Let's see, we got one terminal to the battery, the other meter lead to the battery terminal on the starter solenoid and cranks the engine. Voltmeter displays a reading of 878 millivolts. Tech A says this reading indicates positive battery cable has too much resistance.
Both.
Technician A, let me see, Technician B says that this reading indicates the starter is defective.
Because it's too high for that 878 millivolts, it's not supposed to be higher than 200.
Okay, but is this a current draw test or is this a voltage drop test?
Oh, a voltage.
So what he's doing is going from the battery positive terminal to the battery cable connection at the starter, on the starter solenoid. Okay, from here to here. 870 whatever, 8 millivolts. Actually, that would be a point, and this would be actually volts. What's being checked? 1 meter lead goes here. Let's say this is your meter. One of them goes here, one of them goes here.
Resistance.
878.
Negative.
It's still too high.
It is, but what's the problem? One of them says the cable's bad, the other says the starter's bad. That's what it's asking. What are you checking?
The cable.
You're checking the cable, yeah, it's A. All right, after installing the starter, both A and B. For 10. Okay. Did you have a question?
I was searching.
Okay, you seem to do that a lot, so I'm just not gonna ask anymore. So if you have a question, just bark it out.
Alright.
All right. Before we get into charging system, we're gonna hopefully give you a little bit of a explanation of it.
All right, I got the last foldout. We're ready to tear it apart for today's Garage Edge segment on alternators and charging systems. Welcome back to Tech Garage, presented by RockAuto.com. We're talking about the alternator today. What is the alternator? What does it do? And how does it work? That's important. Well, an alternator is actually a mechanical driven component that charges your car. It charges it when the car's running. That's what happens. The battery supplies all electricity when it's not. When it's running, it's the alternator's job. Well, how does it work? Electromagnetic induction. That's a big word, hence the nice lab coat. We're going to go through here and we're going to look at induction. Now, this is pretty cool because I can actually produce it here on the meter. That's when a wire cuts a magnet here and it induces a voltage. Watch that meter right here. I can actually prove it right here. So as I'm going up and down, you can see that actually flicking from a positive to negative. As I cut through there, I'm actually creating a voltage or a pressure into that wire with electromagnetic induction. Now you can take a look at this animation right here. This is pretty cool because we looked at a starter a couple shows ago. This one here actually shows it spinning. What's happening is the rotor inside of the alternator spinning, it's magnetized and it's inducing a voltage out to those outer magnets, which is actually the stator assembly, and that's what's producing the voltage. I can show it to you right here in action. This would be the rotor, and what's going on, it's spinning inside your alternator. This is what's belt driven. Out here is the stator assembly. Now I have no external power supply going to this, and I can spin it. And you can see, no matter which way I spin it, I'm producing a voltage here. And what's happening is an AC output. You can see that little LED light flicking. It's actually doing it with nothing. Now an alternator, we actually put a little voltage to it. I want to pull one apart and show you everything that's going inside. I got this one ready. I actually took off the voltage regulator right here, which is cool because these are the brushes that supply power to the actual rotor assembly. I'll show you that. Here's my end frame. You got some bushings inside of here. We'll do some diagnosis in the next show. We'll look at what goes wrong with that. And then I want to show you some of the components inside this thing. So if I separate this, you can see the front quarter. And then right here is the heart of the alternator. This is actually the rotor assembly. The rotor assembly has these caulk holes all on here and a big wire winding in there. I'm going to magnetize in a little while because this actually makes a ginormous magnet. And that's what induces voltage into this stator assembly. Now the stator assembly takes that, and there's different phases. It's 3-phase, could be delta wound, could be Y wound, but I'm inducing a voltage in there. but it's an AC voltage, so we have to convert it with a rectifier or a diode trio, some way to send it out as a DC voltage. Now, this is a cool part too, because this feeds the voltage into the actual rotor assembly. Alternator only charges what a battery needs. So what a battery needs is going to be determined by the voltage in on the voltage regulator side, and we're going to magnetize this. Check this out. This thing is a ginormous magnet. Now, this would be demonstrating basically full fielding if I was putting all the voltage to it. So what I'm going to do is I'm going to hook this up right here on this side, and then I'm going to complete the circuit. And when I complete the circuit, I'm going to turn this rotor assembly into a giant magnet. I'm going to get rid of this stuff because it's such a big magnet, it's probably going to slide right into it. So if I put the socket right there and I magnetize this joker like that right there, and then I take that magnet, bam, and I release it, and that goes. I mean, I could put it right there and it pulls it in. I could wheel it up. So that's what's happening. You're full fielding this ginormous magnet. When you full field that, you're actually charging your system and everything's good to go. Now, there's a lot of components here, but Rock Auto has a lot to talk about when it comes to charging systems. Well, the alternator is the heart of the system. It has to produce all that electrical power while the car is running. Tom, the truth of the matter is, I mean, these cars today, they are riddled with electronics, and they keep becoming more and more and more, and the alternator has to keep up, and they're suffering. I mean, they're having a hard time keeping up, creating a lot of heat in the process. What do you guys have for alternators?
Yeah, you're right. You hear about microprocessors doubling their output every 5 years or whatever. Well, there's been a quiet renaissance going on in alternators. Go back to 1955, we have a generator for a full-size Chevy. Generators were kind of like starter motors, one winding. They would not be able to have great output if engine just idling or low RPM. And so I click on the info button, I see, oh, this generator has 30 amp output. Well, if I go 20 years into the future and I look at a 1975 full-size Chevy, see what its alternator's putting out, I see 63 amps. So in 20 years, we doubled the output of the alternator. And we moved alternators and doubled the output.
It's cool to mention we went from a generator to an alternator, so we were able to do that, but keep going, there's even more.
Yeah, if we jump and get ahead another 20 years, go to a 1995 full-size Chevy, the output of the alternators increased to over 100 amps, 105 amps. And then we'll jump ahead another 20 years to 2015, fairly recently, full-size Chevy, and we're up to 170 amps.
Wow. Yeah.
And today's cars, you have electric seats and everything, some cars are well over 200 amps.
Well, stick around. There's a really interesting video question of the week right after this break. There's plenty more. Tech Garage, presented by RockAuto.com.
All right. Rock Auto, anybody buy parts from them?
No.
No?
I've heard the commercial.
Yeah, if you're looking for parts for your car, not a bad place to just go online to rockauto.com. They got lots of stuff. I'm not getting any money for saying that. I've used them before, not a lot, but
Giving you money for saying that.
all right. So let's go back to this and well, you know kind of how an alternator works and what it does. We're going to go through factors determining the alternator's output voltage and current, how the voltage and heat produced by the alternator are regulated. How computer-controlled alternators work. As you know, everything is computer-controlled, right? Everything is computer-controlled now. SAE term for this is actually a generator, but alternator is a common term that we use, okay? The amount of current generated can be increased by, you need to know this because you will see this later, right here.
Increasing the speed of the conductors.
Increasing the speed of the conductors through the magnetic field, increasing the number of conductors passing through the magnetic field, or increasing the strength of the magnetic field. You can increase the alternator output by doing any of those. A good idea to know that. going to be another one similar to that. You're gonna need to know. Also, alternators induce a voltage by rotating which of these? Magnetic field inside a fixed conductor. We just saw that in the video, right? He put power to that rotor and it became a big electromagnet, right? Okay? It's a magnetic field inside a fixed conductor. The fixed conductor is the stator. Okay? Alternators are constructed using a two-piece aluminum housing, bearings obviously for the rotor to spin on. Okay, we already looked at this. This is how you can increase the output of an alternator. One of the reasons when you do an alternator test, you bring the engine RPM up, right? Don't let it idle. Bring it up a little bit, maybe 1500 RPM. Get it spinning, right? A little faster than it normally does at idle at, whatever, 500-600 RPM. Purpose of pulley is to help eliminate noise and vibration in the accessory drive belt system. They use a dampening spring inside. And it may have a one-way clutch in it. Some of the names for those are listed there. Typical V8 Chevrolet. Alternator, pretty much all look the same. End frame is toward the drive belt section. Drive end housing is the rear section or the slip ring housing. Overrun clutch. A lot of alternators have those on the pulley now. So if you buy an alternator, you're going to get the entire alternator, okay? The overrun clutch, the pulley, everything, okay? So when you replace it, you don't typically have to change that pulley over, on the older ones. You'd have to change the pulley sometimes, but on these, you don't have to. Purpose of it is to dampen noises, vibrations in the accessory drive belt system. Okay, we saw the rotor in the video, right? That's the big piece that rotates inside the alternator, right? It has a whole bunch of turns of copper wired, or coated with varnish insulation wound over an iron core. How it creates a magnetic field. The current goes through those slip rings or the brushes that you saw him put on the rotor of the alternator, right? Those are the slip rings on the rotor that he was putting voltage to. What happens is they become alternating north and south magnetic poles, which is one of the reasons it creates an AC current. Remember, it has to be converted to DC, and it's done inside the alternator with a rectifier bridge, a series of diodes. All right? That's what converts that AC to DC. Everybody got that so far?
Say that one more time, please.
The alternator actually produces an alternating current. Okay?
And it transforms that current to DC inside.
Inside the alternator, by means of a rectifier bridge, which is just a series of diodes that converts that AC that the alternator generates into a DC that the battery can use and the electrical system in your car can use.
So AC goes in, DC comes out. and
It
puts back.
produces AC. DC comes out. Yes, right,
Produces
right, right.
AC, it
Mhm.
comes out. Okay, thank you.
Rotor stator diodes. The rotor is the one that rotates, the one you saw him hook the battery to that created a big magnet, right? The stator is actually the stationary windings that the rotor spins around. Diode, semiconductor that operates as a one-way electrical check valve. We know about diodes already. We saw the inside of an alternator. This is a cutaway picture of one. There is your slip rings, and these are the brushes that you saw him apply to there, but he just put the cables on here and here, right, to create a electromagnet out of that rotor. Electromagnetic induction is how the alternator works. works again. Rectifier bridge, we saw this in the last, one of the previous, slides. Rectifier bridge, that's the guy that does the work as far as converting AC to DC. All right, how does it work? We already talked about that. Magnetic field of the rotor generates a current in the stator windings by electromagnetic induction. Induced current in the stator windings is the alternating current because the alternating magnetic field of the rotor. He talked about different types of wound stators. There's a Y wound and a delta wound. Y wound stator connection, the current must combine because two windings are always connected in series, and the other, the delta, is current is induced in each winding. It flows through the diodes in a parallel circuit. He kind of showed us this, right? Again, it's just a magnetic field inside a fixed conductor generating the alternating current. When there's three windings present in the stator, the resulting current is generated, represented by three sine waves. Voltage is 120 degrees out of phase. The connection of the individual phases produces a three-phase alternating current. There's your schematic for your different types of stator windings. Your 6 diodes, remember the test question we saw yesterday? Had a schematic and it said, what is this? One was a schematic.
Yep.
The other was,
It has,
how many diodes does it have, how many resistors does it have, remember that?
yep.
Basically, same thing you're looking at here. Output voltage and current of the alternator depends on speed of rotation, number of conductors, strength of magnetic field. Might want to remember that as well. Stator, 6 rather than 3 normal windings. That is the part that the rotor rotates inside of. In order to keep the voltage at the proper level for your car to operate properly and the battery not to be overcharged or undercharged, you have a voltage regulation circuit or system in the alternator. Control of the field current is accomplished by opening and closing the ground side of the field circuit through the rotor on most alternators. You've heard of the Zener diode already. We talked about him, right? He's a major component that makes voltage regulation possible. The alternator will keep up with the needs of the battery, depending on whether it's overcharged, undercharged. Okay? If it's computer controlled, it will regulate that to keep the battery at the proper charge level. The alternator may supply the needed current, but may not reach maximum charging voltage. Voltage regulators compensate for temperature as well. What's normal charging system voltage?
For the alternator, is it 700?
If the car is off and the battery's fully charged, you're gonna be looking at about 12.6 volts, right?
Wow.
After you start the car, what's the normal charging system voltage you expect to see on the meter?
14, right?
Somewhere in there. Somewhere around 14. It could be 13.5, it could be 14.5, it could be anywhere up to 15, but somewhere in that area, depending on the needs of the battery at the time, okay? Voltage regulator inside. Another schematic for the regulator. Okay. Obviously it generates a lot of heat, right? You gotta keep it cool. It may have an internal or external fan or both. It also may be water cooled or have engine coolant running through it. That might show up on the test as well. Is it possible to have a water cooled alternator or coolant? Okay? Could your cooling system coolant flow through the alternator?
Yeah.
It could. And there's a picture of one right there. Gonna have a couple of hoses hooked up to it. Obviously, that doesn't go inside the electrical part. Water and electricity don't mix.
I've seen like, you know, detailing videos where people like power wash their
Uh-huh.
engine bay and everything. Could that damage the alternator
Not normally.
or the battery?
The only thing you don't want to do for the most part,
Is
if
get
you're
in the
pressure
current.
washing an engine, don't get this wet.
Okay.
These normally have a cover over them anyway, but if you notice it has a little symbol on it. See, you actually got a picture of a pressure washer with a, don't do it.
Okay. So if I were to do that, just cover that up with the.
Yeah, just put a bag over it or something like that. Normally they have a cover over anyway, but
Yeah.
as far as pressure washing an engine, typically you're not gonna hurt anything, but don't do it when the engine's hot.
Got you.
Right? All right. Your computer-controlled alternator will interface with the charging system in a few different ways. The computer can activate the charging system by turning on and off the field current to the rotor, which is pretty much how that works. Computer can monitor the operation of the alternator and increase engine speed if it wants to. Computer can control the alternator by controlling the output to match the needs of the electrical system. If you'll notice, a lot of cars now have a battery current sensor on the cable. That's what that's for. It's part of an EPM system. You've seen that before, basically duty cycle, on time, off time. Duty cycle and approximate what the alternator output would be. As you can see, it could go past 15 volts. Normally, this is what you would expect to see, somewhere in here. Okay? All right. You don't get one. And one for you. Anybody not done? Somebody in the back is not done? Okay.
Number one. I put A.
I'm not done.
Give her a few minutes, guy.
Oh.
I know you didn't see that, but.
All right, I'm done.
Okay, number one is A, we already did that. All effect sensor, number two.
Which of these is true about an alternator with an overrunning pulley? Is it B? I couldn't find anything for overrunning type.
Which one of those makes sense? Must be replaced with the right one, or can you put anything on it? That's what they're saying.
I said use a conventional replacement pulley because that's what it says, but I couldn't find anything on the overrunning type. Where does that say that at? Because I couldn't find that.
That's one of those questions that kind of seems to answer itself. Because, I mean, if your alternator has an overrunning pulley on it, why would you just put a conventional pulley on it?
It says you can use a conventional pulley.
Okay. Can I install an OAP on an OAD 2-watt alternator?
What page are you, cause I
624.
found that same answer that he's talking about on page 623, 624. What did you just read, Ron? What page was that on?
624 in that FAQ.
On that page? Okay.
Well, I see it now.
This means a conventional pulley often cannot be used to replace an overrunning pulley.
So is it just A or could it be both?
No.
Because on here it says it usually, what does it say?
It says usually no.
Usually no. So we're just gonna say no. All right, okay.
Number 3, the output of an alternator can be increased by increasing all of them of the alternator. Any of these.
Okay,
What was that answer then?
D, any.
Okay.
this is a might see later question. Okay,
Number 4, technician A says that alternator overrunning will be used to reduce vibration and noise. Technician B says that an overrunning mechanism or damper is used a one-way cross. Who's right? Is it both?
It's A.
Both.
Is it both? Really?
It's both,
It's
pages
both.
22 and 23.
Yeah.
both of them for number 4.
I have a quick question going back to, number 3. On page 622, I guess I misunderstood it and we're maybe going back to the wording thing. But, I didn't see, okay, so increasing the speed of the conductors is the same as increasing the speed of rotation?
Speed of rotation means engine RPM, how fast is it turning?
Yeah, well, on page 622 for the output of an alternator, or maybe I was looking at the wrong thing.
It's alternator output factors.
627, 628.
Oh,
Should
I was
be
on
where
the
you
wrong
find that,
page.
yeah.
Okay,
1, 2, and 3.
627, 628.
okay, 1, 2, and 3, okay.
Yep, speed of rotation, number of conductors, effective
Oh,
magnetic
okay.
field. Any of those are going to increase the alternator output.
Okay, thank you.
All right, where are we now?
5.
5, okay.
Yeah, both number
V increases, yes, that's correct.
Oh shit, I forgot. No, I already did that.
The voltage regulator controls the current through all of them. I was gonna go with A, alternator brushes. And then I said all of them.
All of them is the right answer. One horsepower is equal to how many watts?
720.
746.
Full five.
Increases B.
Which of these is the stator?
D.
This guy right here. D is the right
It's an
answer.
increase, right?
Yeah.
Okay.
Fine, E.
B. Tech A says diodes regulate the alternator output voltage. They do not. They regulate the AC to DC. B is correct. Field current can be computer controlled.
You said B?
Mm-hmm.
Then is D.
How is the AC current produced in the alternator changed to DC? By diodes inside the alternator.
For number 9, what page is that on? Because I was on page 626. And, I misunderstood that. I put A, but it regulates the AC to DC. And where does it say that the field current can be computer controlled?
Field current is computer controlled if the alternator or if the car has a electrical power management system on it, which most of them do.
Okay. That's
Computer
fine.
controlled alternator 630.
All right, that.
Okay, everybody knows what duty cycle is, right? If something has a 90% duty cycle, is it on most of the time or off most of the time?
Duty cycle.
A 90% duty cycle?
Is it on most of the time or is it off most of the time?
On.
Right, because it's a 90% duty cycle. It's on 90% of the time and off 10% of the time, right? You're gonna see that later too. So I put that up here. All right. Next one, 54B. This is a question that you are going to have to remember if you want to do well on the test. Alternators induce a voltage by rotating which of these?
Stator inside a magnetic field. Magnetic field inside a fixed conductor. Okay.
Magnetic field inside a fixed conductor. We saw that in the video, right? The magnetic field is the rotor once it has power to it. Rotating inside the fixed conductor, which is the stator. So alternators are cooled by intercoolant.
True.
Yes.
They are. Duty cycle
False.
means it's off most of the time. No, it's on most of the time. This is another question you might want to think about. What's the answer to it?
Technician B.
Condition B. One of these is stator, we did that already, it's this guy right here, right? Any of these can increase alternator output. Current for the rotor flows through brushes to what?
Regulator.
Nope.
B.
D? No.
No, B.
Oh, B, no, not B either.
So A.
Slip rings on the rotor. Those are the two little things that the brush is right on that you saw him put the battery power to that created the electromagnet in that rotor. Alternator brushes, what are they?
Copper.
The silver, copper, alloy, or regular copper.
Brushes are carbon.
Or brushes.
Alternator brushes constructed from carbon. Electric power management system has 3 modes of operation.
True.
No. Current is produced in what?
Stator.
Stator, correct. All right, that is that. Okay, our last chapter we'll do after lunch, but for now, going to do a couple of these quick little quizzes here. This one is only 6 questions. Didn't have any problem with this. Hopefully. Yep, now you get one.
Have you done number 2?
Hmm?
Have you done number 2?
I'm looking at it now.
A and B are like exactly the same.
No, they're all different. I think it's probably D.
Oh, I see. Charging.
Yeah,
That's
because this
one
one
word.
goes from verifying concerns to inspecting battery connections and then testing battery condition and check charging circuit. So I think it's probably D. Everything else is just, really close to similar and backwards, but they have alternator in there. I think you need the alternator.
Okay. Let's do this. Oh, one of you lucky people does not get a question since there's only 6. Who's gonna be a lucky one?
What are the components of the proper operation of the starting system?
I guess it's gonna be Terrence who's gonna be the lucky one, since she started. Okay, what is it?
I think it's C.
Think it's what?
C.
C?
Yeah. Is it? Please tell me I'm right.
Starting system does not include the alternator.
B.
Battery cables, battery, starter motor.
I knew it.
Everybody get B?
Yeah.
Yeah, anybody not get B,
Stop bragging.
other than you? Okay, number 2, how'd you do with this one?
Is it D? Might be wrong.
What'd you get, Nasser? We're giving you number 2.
Oh shit, I thought you were just asking in general.
You just went with A, why? You don't know? Okay, well, A is the right answer.
Shit.
Obviously verifies customer concern, inspecting the battery and the connections. Test the battery condition, check the control circuit. Those are what you would do. Number 3. Charles, you're number 3.
Yeah. What is the voltage drop test input? Is it B?
It is B. Trying to locate high resistance areas in the cranking or charging circuits. Number 4, what's included in the control circuit?
A.
The battery, the ignition switch, clutch switch or neutral safety switch, step deterrent system, starter, solenoid is correct.
Hey, there's only 6 of us in here. That means everyone's gonna agree. If Image was here, then someone would be up.
Oh, that's right.
What
There is 6 of us in here, sorry.
What are some possible
I'm used
causes
to there
of
being 7, so, okay. Everybody gets a question, sorry, Terrence.
what are some possible causes of an inoperative starter? Would that be C?
It would be what?
C?
A.
What is it?
B.
It is B. Inoperative starter,
Inoperative.
meaning it doesn't work at all. Neutral safety or clutch switch, blown crank fuse, open, meaning nothing's happening at the ignition switch, starter relay, or control module.
When should a starter merge test,
Amperage test be performed.
amperage checks be performed? Put B.
Routine part of electrical system inspection, not normally.
A.
No.
C.
C. When the starter fails to operate normally or as part of a routine electrical system inspection, so B isn't quite a bad answer, it's just not the most correct answer. All right.
The phase,
I'm sorry.
the phase,
Oh, the quiz.
Oh, the book quiz?
Yeah.
See. All right. You should know the answer to number 1. Do diodes regulate the output voltage of the alternator?
No.
No.
They switched them, right? No, they.
Does the field current, could it be computer controlled?
Yeah.
Yes.
so it's B.
It is B, yes. Let's see how you do with number 2. If you were paying attention to the video or with anything that went on in the last chapter or 2, you should know number 2.
C. C cat.
Yes. Magnetic field is created in the rotor. We saw him do that, right? It's used to induce a voltage in the stator. All right, number 3.
Diodes inside the alternator.
Yes. The AC voltage produced in the alternator is changed to DC through the diodes inside the alternator.
Is 4B,
Let's see. 2 diodes required for each stator wire lead. Diodes change the alternating current, direct current, both of them.
I thought it was more than 2 diodes, it's not more than 2 diodes?
For each stator winding lead.
For each stator, yeah.
So the stator winding could have 3 leads, could have 4 leads. So 2 for each one is what it's saying.
Oh.
For each
okay.
lead, not for each alternator. Most alternators will have 6 or 7 diodes. Or it could have, I should say. All right. Alternator output current is produced in the, I think we did this one already.
Rectifier.
Nope, that is what converts the AC to DC.
It's in the.
Current is produced in the what? That question was answered in one of the previous questions we just did.
Stator.
Stator. Number 6 we did, right? Any of these would increase the output of the alternator. How much current actually flows through the alternator brushes?
Is it 10 to 15?
B.
What is it?
B.
It is not to be either.
Okay, all alternators contain 6 diodes, 1 pair of positive and negative for each of the 3 stator windings. All alternators contain 8 diodes with another pair connected. Oh, here's what that is.
Okay. Anybody get the right answer to that yet?
Is it B?
Is it D? It is. Less than 3 amps. Trying to find the page
What
number.
page is that on
Oh, I'm trying to find it.
Is it rotor current, the current necessary for the field windings is conducted through slip rings with carbon brushes?
Mm-hmm.
The original, the current for the field is controlled by the voltage. The brushes conduct only the field current, which is usually between 2 and 5 amperes.
There you
That's
go.
on page 625.
All right. Tech A says an alternator overrunning pulley is used to reduce vibration and noise. It is.
We did this one, it's both.
We did, right? It is both. Okay. What is used to help control heat created in the alternator?
All of them.
Any of those. How does the computer interface with the alternator? All of these are possible.
What was number 8?
8?
Both.
Okay.
Yeah. 8, both, yeah. Okay, the last chapter that we have to do is 55, we'll do after lunch. That's just the diagnosis and service of the charging system. And we'll do that when we get back. Let's be back at 12:25 instead of 12:30, okay? Should